All right, everybody, this is Mr. Lloyd. I just met most of you yesterday, and today is our first day at a blended classroom where I show you a video that you watch, you take some notes, and then you work through our workflow that I'm looking at right now. This should be the set of notes you're looking at. Hopefully you downloaded these or picked up a paper copy under the television. We're going to do a little bit of this and a little bit of that. I am not going to fill in the notes specifically on here, but I'll be working below and trying to give you a shorter version of my original marathon movie, which was 10 minutes long. So let's begin. First and foremost, let's talk about the order of operations. I abbreviated OOO, and that order of operations is please excuse my dear Aunt Sally. Just to remind you of those things, the parentheses stand for parentheses, but any grouping symbol will work. You might see a bracket, you might see a square root symbol, you might even see a fraction bar where the top is separate from the bottom. Those are all examples of grouping symbols or parentheses. The second piece you'll see is an exponent. A reminder that an exponent is, let's say, 5 to the third. The exponent is the little number up and above, and what that little number means is that we would write the base number, in this example 5, 3 times, and we'd multiply them together. In this case, I'd get 125. That is what an exponent is. MD, my dear, is multiply or divide from left to right. It's pretty key that we do from left to right. And then AS is for add and subtract, again, from left to right. Be especially attentive if we did something where multiplication was involved. Let's say 4 divided by 2 times 3. I'm just making something up. In this example, you would have to multiply first, because that's what you would have to divide first because we have to run our order from left to right. So from left to right, the first thing we do is 4 divided by 2. 4 divided by 2 is 2, and 2 times 3 is 6. So the correct answer to this problem, the way it's written, is 6. Similar thing for add and subtract, since you've seen that before, and my goal is to make this video short. I'm going to move on right now with you knowing the order of operations and specifically knowing some of the additional grouping symbols that you're going to need to be aware of. Oh, and one I forgot, which you would want to include, absolute value. A reminder about absolute value, if you had something like -3 inside an absolute value, the absolute value of -3 is 3. It's that positive version of the number. All right, next up. What is the difference between exponents? Sometimes you're going to see exponents like 5 to the third power. We've kind of already gone over that one, and they'll work out pretty easily. But sometimes you're going to see things that involve negative signs. Let's say if we had a -3, now that's the example. So how about -4 to the second power versus -4 in parentheses to the second power? And the question is, are they the same? Are they different? And if they're different, how? What I would want you to observe is this. When you see an exponent, whatever the exponent, too big, whatever the exponent is physically touching, notice how this 2 is jammed right up against the 4. But I'm not including the negative because the negative isn't next to the 2. It's just this 4 here. That's the only thing that gets written twice. So that would be negative, and then this green part here becomes 4 times 4. So the negative just kind of comes along for the ride. We get negative and then 4 times 4, which ends up being -16. So you'll find that even though we're squaring what sounds like a negative, we end up getting a negative answer. If you see on this piece, same idea, this exponent is touching this right parenthesis. Now, it doesn't mean the right parenthesis twice. It means the parentheses are the things that you write twice. So in that case, we have parentheses written twice. Or if you prefer, parentheses written twice that are being multiplied together. Now inside the parentheses, they're both -4s. You might recall that if they're the same signs, they become positive. And notice how these two numbers are different from one another, which means how you write the problem matters. If you have them in parentheses, then you have both negatives included, and you tend to have a positive answer. And if on the left-hand side here, you do not have a negative in parentheses, but you have it kind of on the outside, it continues to float and will often show up in your answer. So be aware of that, as they are different things. Now, next piece. When we deal with adding or subtracting integers, this double Z here, this capital Z that I made, that's another thing for integers. If you prefer the spelling, there it is. Now, when you're adding integers, let's say you're adding 3 plus 4 or -2 plus -7, the rule generally is if the signs are the same, you add. All right, so in this case, I'm going to go ahead and add because the signs are the same. So on the top, I get 3 plus 4 is 7. On the bottom, I get 2 plus 7, and I get 9. And then I guess I better keep the sign. And this is what I get. If you have different signs, let's say we take a 3 and a -4, or a -2 plus a +7. Those are different signs because one of them is positive, one of them is different. What you're going to do is you're going to subtract and keep the bigger sign. And what I mean by that is 4 minus, in the first one, 4 minus 3, notice I'm not even dealing with the negative signs. 4 minus 3, that's the subtract part. 4 minus 3 is 1, and the bigger sign, that means there's more negatives than positives. The -4, there's more negatives than there is positives, right? There's 4 negatives and only 3 positives. So the bigger sign is negative, so I make my answer negative. On the one below that, I'm going to do the same thing. My signs are opposite. So subtract 7 minus 2 is 5. And the bigger sign in this example, you might guess, is it -2 or is it +7? The bigger sign is most definitely positive, so I'm going to go ahead and put a +5. And nobody really writes the plus in front of a positive number, so we'll take that out. So that is the deal for adding integers, whether they are the same signs or different signs. For subtraction, generally speaking, I believe last year you guys might have learned KFC, someone told me earlier today, where you keep, flip, change. That works really well. If you learned it slightly differently, another phrase that I've heard would be keep, change, flip. In reality, it's exactly the same. Or if you really kind of want to go crazy, the one that I was actually thinking of was keep, change, and let's get rid of this one altogether. Keep, change, change. All three of those, whether it's this one, whether it's this one, or whether it's this one, they all mean the same thing. If you have a problem, let's say -4 minus 5, for example, you keep the first, I'm going to color code this, right? So you keep, no matter what phrasing you use, you keep the first number exactly the same. The second one you do, switch the colors here, when you go to flip or change, that means go to the second item and you flip or change it. Now it's minus, so I'm going to change it to plus. And then the final piece will be you're going to change or flip the last item. In this example, this 5 is positive, so I'm going to change or flip it to negative. And now that I've had that done, I can refer back to whichever one of the rules up above applies best. In this example, my signs are the same. So I'm going to add and keep the sign. So this becomes -9. When we're dealing with multiplying and dividing integers, multiply or divide integers, there was a rule that if the signs are the same, like a positive times a positive, then you get a positive. And if the signs are the same, even if they're negatives, you still get a positive. Now, this works in even number pairs, so if there's a pair of them, then they cancel out and you get positives. If there are a pair of different symbols, let's say positive times a negative, or if you reverse the order, negative times a positive, then your answer comes out to be negative. No worries there. You should remember that. It works the same for division, so I could literally copy-paste this thing. I guess I can quite simply do that. And you would get exactly the same rules if you just used division. And whether the division is written with the division symbol or whether you write it as a top and a bottom like a numerator and denominator, either way it works exactly the same. Something to be aware of, if you find yourself with more than one number, more than two numbers, let's say -2 times -3 times +4, you simply take the first two numbers and apply the rule. So -2 times -3 is +6, and then bring down this number you haven't used yet, and then multiply the next piece. Right? And that'll help you keep your negative signs and positive signs straight. To evaluate an expression is the next thing on your notes. Evaluating an expression simply means you're going to substitute a number into a value and then figure out what that value is. And I'll give you one example, maybe two, and that'll be it for this video, or it'll go too long. Let's imagine that I take the value a and say it equals 2, the value b and it equals 5, and the value c and it equals -4. We'll go with something a little different. If I ask you to evaluate, let's say 3ab minus c, using those numbers above, then what I'm going to do is I'm literally going to take out the a, which is written right next to the 3, and take out the b, which is written next to the a, and take out the c, which is written after the minus sign, and instead of a, b, and c, I'm going to replace it with the numbers 2, 5, and -4, exactly like it told me to. And now I follow my order of operations. I see multiplication here, times 5 minus -4. I see multiplication again, minus -4. I rewrite the steps every time. Now, I'm still in order of operations, technically speaking, but I have a minus problem with integers. So I'm going to go back up to my notes. Where were those things? Here we go. They're highlighted. I'm going to go with the KFC, the chicken one. Keep flip change. I kind of like that one this year. So I'm going to keep the first number. I'm going to flip the minus and make it a positive. That's the keep flip. And then change the -4 changes to +4. And believe it or not, all of that mess turns into 34. And that's that. A couple things to keep in mind. If you have an absolute value symbol and we have numbers on the inside of it, what you need to do is combine those things on the inside. Those numbers are the same. Sorry, they are different symbols. I'm going to subtract them. 3 minus 2 is 1 and keep the larger sign. And then I go ahead and ask for the absolute value. Remember, the absolute value is simply how far is this number from 0. And the number 1 is exactly 1 space from 0. So 1 space or just plain old 1 is a correct answer for absolute value. With that said, I'm going to wish you the best of luck. You'll be able to at least begin your Get More Math from here. You will likely run into some things that involve exponents. As part of a problem, you might see something like this. Don't be scared off by that. You simply do the stuff on the inside. 4 divided by -2 is -2. And as we saw up above, -2 squared. I'll get my highlighter again. It used to be green. This is touching this. So now we're going to go ahead and write this twice. And -2 times -2 is +4. So you can manage all of this. I'll be around to help. Just throw your hand up if you need something. And otherwise, good luck with Unit 0, Day 1.